Hi friends, we will discuss one more problem in single phase off wave rectifier. So the problem is a 230 volt 50 Hz 1 pulse SCR control converter is triggered at a firing angle alpha is 40 degree and load current extinguishes at an angle of 210 degree. Find circuit turn off time. Second one is average output voltage and load current for R is equal to 5 ohm and inductor value L is equal to 2 millihenry. So this is the question asked to us. So whenever we see this part, so whenever we see this part, controlled one pulse SCR control. So one pulse means it is off wave rectifier. Okay, that we have to know. And its control rectifier converter is triggered at firing angle alpha is 40 degrees. So this is alpha. Load current extinguishes at an angle of 210 degrees means this is beta extinction angle. Okay, so this is beta and this is alpha. So alpha has been given, beta has been given, such that it is with RL load. So extinguishing angle is also there, extinction angle is also there. So we have to see it. So circuit turn off time, so when the thyristor will turn on. Okay, when the thyristor will turn off, what is that particular period? So if I can see from 0 to 2 pi, the thyristor will work from alpha to beta, but the thyristor is in forward bias from 0 to alpha also. So I can say that from 0 to beta, my thyristor may conduct. Okay, so whenever I give alpha, for example, if alpha equal to 0, the thyristor will conduct from 0 to beta. Okay, so in that way, what is the time for making my thyristor to turn off is, it is simply 2 pi out of 2 pi, beta is turn on, I can turn on, so 2 pi minus beta divided by omega. So this is the thing for circuit turn off time in this particular case. So this particular case is with RL load, that's why my thyristor will turn on from alpha and it extinguishes at beta. So let me take these things here, 2 pi minus beta divided by omega. Okay, so it is 2 pi. Yeah, here beta means I have to write it in the I have to write in pi form only. So how to write beta in pi form? So to write beta in pi form, let me simply have it. So what is pi? Pi is 180 degree and beta. What is beta? So beta is that we have to see actually, sorry, beta should be written, given, beta has been given in degree. So let me write 120 degree here and I have to find this part, x part. So it should be pi by x is equal to 180 divided by 210, which implies what is x? X is equal to 210 divided by 180 into pi. That means we are simply getting the beta value in terms of pi. So it will, these two will get cancelled. It is 3 sevens are and 3 6 are. You can simply maintain this, not an issue. 7 by 6 pi. Okay, so it is 7 by 6 pi divided by 2 pi f. 2 pi f. F means it is 50 hertz, so it is 50. So which is equal to, let me cut all pi's. Okay, then 6 2s are 12 minus 7 is 5 divided by 100. So it is 20. So yeah, even 6 is also here. 6 is also here. Okay, this part is there, no? 6. So finally, the value will come around 8.33 millisecond. So this is the time for circuit turn off time. So now I will arrange all these things and I will utilize this space for calculating average voltage and average current. So now we have obtained everything. That means, what does it mean by which load is it? It is RL load, so I have to go ahead with the same formula. So what is that formula? V naught average is equal to, this is RL load, so the formula will be Vm by 2 pi cos alpha minus cos beta. Okay, so the derivation of this part has been discussed, it was discussed in the previous video. You can go back and see it, or I will give it in the description box. So simply substitute here. 2 Vm is root 2 into 230. So whatever the value it has been mentioned here, it is always be the RMS value. So for getting maximum value, we have to multiply RMS value with root 2. Okay, please remember this. Divided by 2 pi into cos alpha is 40 degree minus cos 210 degree. So by using calculator you can get those values, and finally the answer will come around 84.489 volt. And the average current, load current, will be I naught average is equal to V naught average divided by resistance R. So it will be equal to 84.489 divided by 5, which is equal to 16.8978 ampere. So these are the answers. So whenever in problems they are not mentioning directly such that this is an off wave rectifier or we are dealing with RL load. Okay, they will directly give the values, they are directly give the things. Okay, but they won't say directly such that it is off wave rectifier or full wave rectifier or anything else. As we are in the off wave rectifier problem solving, we felt it's easy, but once we go ahead with the off wave and maybe with full wave, maybe with semi converter, full converter, then it will be a confusion. Okay, so please keep those things in your mind and read the problem carefully and go accordingly. Okay, if you have any more doubts, you can please simply post in the comment window so that I can reply you within 24 hours. Thank you so much.